Good day, grade 12 learners. Welcome to today's technical science lesson. My name is Lebogang and my surname is Teledi. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So for today's knowledge area, we'll be focusing on matter and material, which has a total of 47 marks. And today's topic will be focusing on organic reactions, which is question 4 on your exam for paper 2, and it consists of plus minus 13 marks. Okay, so in terms of the mark allocation for paper 2, you have section A, which consists of 5 multiple choice questions, and that has a total of 10 marks. We also have section B, which consists of structured or long questions, and it consists consists of a total of 65 marks, and the total for paper 2 is 75 marks with a duration of 1 hour 30 minutes. Now the topics to be covered in paper 2, we have matter and materials, which has a total of 47 marks and a percentage weighting of 62. We also have chemical change, which has a total of 28 marks and a percentage weighting of 38. In terms of the examination guideline, that is for your organic reactions. It says reactions of organic compounds, and then we have oxidation, combustion of hydrocarbons. So what are hydrocarbons again? That will be compounds that have a combination of hydrogen and the carbon. So therefore the word hydrocarbon. And then it says you need to write down an equation for the combustion of hydrocarbons in excess oxygen. Then it says we need to know what substitution and addition reactions. Identify reactions as substitution or as addition. Write down using structural formulae equations and reaction conditions for the following addition reactions of alkenes. So when it comes to addition reactions, we'll be doing addition reaction in terms of In terms of alkenes only. So the first reaction that we have there is your hydrohallugination, and that is the addition of The addition of a hydrogen halide to an alkene. So hence the word hydro and halogen, because we are going to be adding the hydro part is the hydrogen, and then the hallugination part is a halogen. Then it says hallugination. It says the reaction of a halogen, so Br2Cl2 with a compound. Then we have hydration. It says the addition of water to a compound. So remember water again, the molecular formula of water is what? The molecular formula of water is your H2O. Then we have hydrogenation. It says the addition of hydrogen to an alkene. So remember with your hydrogen, when you add it, it's going to appear as As a diatomic molecule, meaning that it will not appear as a single hydrogen, but you are going to have H2. Next, it says the examination guideline says you need to write down structural formulae, equations, and reaction conditions for the following substitution reactions. So the hydrolysis of haloalkanes, hydrolysis, that is the reaction of a compound with water. And again, remember we said water is the molecular formula of water is your H2O. Then it says the reaction of HX, so the H is our hydrogen, and then X in this case will represent the halogens. So for example, we can use We can use Cl, which is a chlorine, and Br, which is a bromine. So it says the reactions of HX with alcohols to produce haloalkanes. Next, we have a halogenation of alkanes, And then it says the reaction of a halogen, that is Br2Cl2, with a compound. Okay, then next we need to know plastics and polymers. So the examination guideline says you need to know only the basic polymerization as application of what? Of organic chemistry. And then with that you need to describe the following terms. The first one there, it says a macromolecule. So it says a molecule that consists of a large number of atoms. So remember, with your definitions, you are going to get what? You are going to get either 2 marks or nothing. Then we have a monomer and a polymer. And that is according to the examination guideline. So we'll start with the monomer. It says it's small organic molecules that can be covalently bonded to each other in a repeating pattern. So when we speak of a covalent bonding, that is just a bond between two nonmetals. So for example, the carbon and the hydrogen. So a bond between 2 nonmetals. An example in this case of our monomer would be the structure of what? Of the ethene. Then it says we need to know a polymers. It says a large molecule. So a large molecule composed of smaller monomer units. So this is our polymer. And then it says it consists of a smaller, so it consists of a smaller monomer units that are covalently bonded to each other in a repeating pattern. So in this case, if we have our monomer as an ethene, then the polymer, so the word poly in this case, it means many. So the polymer in this case would therefore be called a polyethene. Poly meaning we have many of the what? Many of the ethenes, and this many of the ethenes, they are therefore in what? In a repeating pattern. So it says here double bond opens up. That is here on the double bond of the ethene, and it says each carbon can therefore be able to make what? It can therefore be able to make new bonds, and then it says new bond links the repeating units together to form a chain. Okay, then it says you need to know polymerization. So polymerization, now it says a chemical reaction in which monomer molecules join to form a polymer. So it would be a chemical reaction that is there in which this monomer units are going to join to form what? To form a polymer. Then it says identify monomers from given addition polymers. So we said if the monomer is your ethene, and this is the structure of the ethene, then the polymer, so it means many of the ethenes, would be represented by the structure over here. Then it says the structure of the polymer can be represented by what? By CH2 and N outside of the brackets. So the CH2, it's this carbon and the what? Carbon and the hydrogens. So carbon and the hydrogen, so CH2 and what? And CH2. And then it says where N can be several thousand. So it means that this N in this case means that we can have a lot of monomer units that are in a repeating pattern. So instead of us drawing all of them, we can therefore write an N to show that we have a lot of this structure over here. Then next we need to know plastics. The definition, it says synthetic materials derived from organic compounds Then the examination guideline says discuss the industrial uses of polyethylene. So we can use it for plastic bags, for toys, and for molded objects. Then again, whenever you are doing your organic chemistry, you always need to keep the following in mind. The first one here, it says alkanes. And then alkanes, you need to know the structure of the alkanes. You also need to know the name of the functional group. So if the name of the functional group, it says only CH and carbon-carbon are single bonds. Then you need to know alkenes and its structure. And the name of the functional group is carbon-carbon double bond. And the next one is alkynes and its carbon-carbon triple bond. And then you need to know haloalkanes and the structure of haloalkanes, alcohols and the structure of the alcohol. So how will you see an alcohol? You will see it by what? By the OH group there. And the name of the functional group is the hydroxyl group. Then it's aldehydes. Aldehydes, it's C double bond O and the H. And the name of the functional group is called what? A formal group. Then we have ketones. So ketones, you have the C double bond O and it's in between two carbons. The name of the functional group is called a carbonyl group. Then we have carboxylic acids, it's C double bond O and then OH. And the name of the functional group is called a carboxyl group. And then we have an ester, which has a C double bond O and an O, but this is going to be in between what? In between the two carbons. So learners, if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. So if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. Okay. Then IUPAC naming, again, when you are doing organic reactions, you need to keep the following in mind. So that is your International Union of Pure and Applied Chemistry. So remember, if you have alkanes, the name ending is ane. So if you had a carbon, if you had a molecule that had 5 carbons, the name would therefore be called what? A pentane. And then alkene, it ends with the -ine. So therefore, if now you had the very same carbon, the very same molecule with 5 carbons, instead of the ane here, you are going to replace the ane with the -ine. Next, if you had an alkane, instead of the -ine, we are going to replace the -ine with the -ine. So this one would be a pentene, this one would be a pentyne. And then if you have alkyl halides, again, the name ending would be the same as that of what? Of the alkanes. So your name ending would be a ane. Aldehydes, our name ending will be al. Then ketones, our name ending in this case would be on or one. And then we have alcohols. Remember, we have primary, secondary, tertiary alcohols, and our name ending would be ol. Then we have carboxylic acids, so our name ending would be oic acid. So for example, this would therefore be a pentanoic acid. And then we have esters, and our name ending there on esters would be what? The O8. Okay. Then we have oxidation reaction. So it says oxidation reaction is one of the special type of reaction, also called a combustion reaction. So if you are in the exam and if they use the word oxidation or if they use the word combustion, it means that they are asking for the very same thing. Then it says oxidation reaction, it is a reaction of oxygen. So it is a reaction of oxygen with alkanes or what? Or alkenes. So remember, your alkanes, they have what? Your alkanes, they have single bonds, and your alkenes, they have your double bonds. So the reaction of oxygen, so oxygen would be represented by what? Would be represented by the O2 there, because it's a diatomic element, so it cannot appear alone. Hence, that's why it will be a constant. So it will be exactly like this as an O2, and you are not going to write it in this way as a single element. Then it says product formed is always going to be CO2, that is your carbon dioxide. So you also have water, that is H2O, and you also have what? Your energy there. Okay. So it says combustion of propane. So remember we said if they say combustion or if they say oxidation, it means that they are looking for exactly the same thing. So it says propane is the gas used in Bunsen burners in the laboratory. And then it says propane burns as follows.
Excellence. Excellence is a habit. Excellence is a quality you have, a quality I have. It's a quality we have when we honor what is true to us. Yes, we are gifted differently. uNkulunkulu akasinganga ngokufana. Excellence is striving for your best. Whenever you have a particular project, test, homework, uzibuze, ask yourself, is this my best? Can I put in more effort? Excellence is striving to be in the top 1% of the area in which you are gifted. And so I challenge you, in every single thing that you do, in every single area that you are gifted in, whether it's sports, it's academic, ucula, whatever that gift is, strive for excellence. Attitude of gratitude. What does that mean? An attitude of gratitude is the quality of being thankful. It's the quality of giving thanks. Ubonga, ulebuha. It's to be grateful. You and I have so much to be grateful for. You and I have parents who make sacrifices day and night for us to be at school. You and I have people who believe in us when we don't believe in ourselves, who love us when we don't love ourselves, who invest in us day and time again. Whether it's a teacher, it's a principal, it's a driver, it's a guardian, we have so much to be grateful for. And so I challenge you, who love us when we don't love ourselves, who invest in us day and time again. Whether it's a teacher, it's a principal, it's a driver, it's a guardian, we have so much to be grateful for. And so I challenge you, young person, be thankful, ubonge, lebuha, be grateful each and every single day of your life. Strive to display an attitude of gratitude.
Welcome back. Welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. So if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. Okay. So it says propane is the gas used in Bunsen burners in the laboratory. Propane burns as follows. Okay. So if they ask you to do a combustion reaction, this is what you are going to do. So you, what are you given? You are given propane. Initially, you can draw the structure of propane. So we know that the homologous series of propane will be what? Will be an alkane, because the name ends with the "ane". So therefore, and then it's going to have what? Therefore, it's going to have single bonds. Then it says prop. So prop means that we have 3 carbons. So this is then your 3 carbons. Then you can draw your hydrogens as well. So we know that we will have 3 hydrogens on the first carbon. And then on the second carbon, we are going to have 2 hydrogens. And on the third one, we are going to have 3 hydrogens as well. So from there, you need to write a propane, the molecular formula of your propane. So how many carbons does this propane have? We can see that the propane has 3 carbons. So hence the C3 there. And then we are going to check how many hydrogens does this propane have. So it's 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So therefore we are going to write C3 and what, an H8. So again, remember we said that we are always going to add our oxygen, and that your oxygen needs to appear as a diatomic molecule, meaning that you are not going to write oxygen as O, you are always going to write it as what? As O2. Then it said that the products that you are always going to have will be what? Your CO2 and your H2O, and then again you are also going to have what? Energy as well. So remember, with this combustion reaction, you have what? You have your reactants. Your reactants appear on the left hand side of the equation, and then you also have what? You also have your products on the right hand side of the equation. Okay, so what is going to remain the same on this reaction? For all the combustion or oxidation reactions, the O2, the CO2, and the H2O and the energy are always going to remain the same. But what is going to change? Only the coefficients are going to change. So after you have written your reaction, the next step is that you need to do what? You need to make sure that you balance your reaction. So how will you balance? You will write carbon, hydrogen, and oxygen on the left hand side. Then you write carbon, hydrogen, and oxygen on the right hand side. Because initially, what is it that you have? Initially, you had H3, H8 plus by O2 to give us what? To give us CO2 plus by your H2O. So that is what you had initially. So then you are going to say, how many carbons do I have on the left hand side? So on the left hand side, initially we had 3 carbons. Then how many carbons did you have initially on the right hand side? You had 1 carbon. And then how many hydrogens did you have initially on the left hand side? You had 8 hydrogens. How many hydrogens initially did you have on the right hand side? We can see that you had 2 hydrogens. Then how many oxygens did you have on the left hand side? You had 2 oxygens. How many on the right hand side? You have, from the CO2 you have 2, and then from the water you have 1. So it's going to be the 2 on the side of the carbon dioxide plus by the 1 on the side of the water. So 2 plus 1 would therefore give you a total of what? A total of 3 oxygens. So from there you need to look at what is it that you have so that you can balance. So I can see that I've got 3 carbons on the left and 1 carbon on the right. So how can I balance this reaction? I can write a big 3 on the CO2, and then if I write a big 3 on the CO2, how many carbons do I now have on the right hand side? So I no longer have 1 carbon, but I have a total of what? Of 3 carbons on the right hand side. Then I check, are my carbons balanced? They are balanced because on the left hand side I have what? I have 3 carbons, and then on the right hand side I also have what? I also have 3 carbons. So from there you move on to the next one. You can either move on to the hydrogen or you can move on to the oxygen. But let's look at the hydrogen. I can see that on the left hand side I have how many hydrogens? I have 8 hydrogens. And then on the right hand side, how many hydrogens do I have? I have 2 hydrogens. So what is it that you can do? You can therefore add a big 4. You can therefore add a big 4 on the right hand side. Okay, so like this one here. So if you add a big 4 on the right hand side, how many hydrogens do you now have on the right hand side? So it will be 4 multiplied by 2. 4 multiplied by 2, it gives you a total of what? It gives you a total of 8. So you check again to say, how many hydrogens do I have on the left hand side? I have 8 hydrogens on the left hand side. How many hydrogens do you have on the right hand side? You can see that you have a total of what? Of 8 hydrogens on the right hand side. From there you move on to the oxygen. The oxygen, how many oxygens do you now have on the left-hand side? You said you have 2 on the left-hand side. And then since you made changes, it means that the oxygens on the right-hand side also changed. So on the right-hand side, the oxygens you are going to have from the water, it will be 4 multiplied by 1. So the oxygen here for the water will be how many? You will have 4 oxygens. And then from the CO2, you will say 3 multiplied by 2. So 3 multiplied by 2 is a total of what? It's a total of 6. So therefore you'll say 6 plus 4, which is a total of what? Which is a total of 10 oxygens. So from there, you are then going to go back to the left-hand side and check how many oxygens you have. So you will see that on the left-hand side, you have a total of what? Of 2 oxygens. And on the right-hand side, you have a total of 10 oxygens. So what is it that you can do to make sure that you balance the left-hand side? So you can multiply the oxygen with a what? With a 2. So therefore it will be 5 multiplied by what? 5 multiplied by 2, and you will have a total of what? You will have a total of 10 oxygens. So again, you check how many carbons do you have. So once you are done balancing, you can go and double check how many carbons do you have on the left hand side. So you have 3 carbons on the left hand side. And then how many carbons do you now have on the right hand side? You have 3 carbons on the right hand side. Then you check your hydrogens. How many hydrogens do you have on the left hand side? You will see that you have 8 hydrogens on the left hand side. Then 4 multiplied by 2. So how many hydrogens do you have on the right hand side? You will see that on the right hand side you have 8 as well. Then you can check the oxygens to say by the O2 on the left hand side, how many oxygens do you have on the left hand side? You will see that you have a total of what? Of 10 oxygens on the left hand side. And on the right hand side, we said we have 3 multiplied by 2, which is what? Which is 6 for the CO2. And then we said 4 multiplied by 1 is what? Is 4. So therefore 6 plus by 4 will give us a total of what? A total of 10. So what you just need to remember for the combustion reaction, you need to write your reactants. And the only thing that will change in terms of your reactants will be what? Will be this compound here. It will either be your alkanes or your alkenes. But the O2, the CO2, and the H2O and the energy as well are going to remain the same. Again, what will also change, it will also be the coefficients, because you are going to be balancing different alkanes and different what? Alkenes. Then in terms of your organic reactions, so this is what we have. If we have a total of 4 carbons, and if you have a total of 4 carbons and you are going to add H2, the type of reaction would be called a hydrogenation. So if we moved from this double bond here to get to this one, what did we do? We had H and H. So therefore the H and H were added where we have the double bond. So the H and H, or the hydrogen and hydrogen, they were added by carbon number 2 and carbon number what? And carbon number 3. So therefore the type of addition reaction is therefore called hydrogenation. Why hydrogenation? Because it is the addition of hydrogen. Now the reaction condition that we need for this reaction will be PT, which is platinum, PD, palladium, Ni, which is nickel. Then next we have a Br2, which is Br. So if we have a double bond here, then it means that the Br and the Br are going to bond there by carbon number 2 and carbon number 3. So the addition of Br2 is therefore going to be called halogenation. Then next we have HBr. So with HBr again, where we have the double bond, that is where we are going to be adding the Br and the H. So the type of reaction is therefore called, so we have an H and we also have what? A Br. The type of reaction is called hydro for the hydrogen part, and what? And halogenation, because it is the addition of a what? Of a halogen. Just like this one, halogenation, the addition of a what? Of a halogen. Then we have H2O. So the H2O separates into H and OH, whereby we are going to add on carbon number 2 and carbon number 3, we are going to be adding the hydrogen and the OH. So the addition of water is therefore called what? Your hydration. And for hydration, this is the H2SO4 is your sulfuric acid, which is therefore your reaction condition. So on the next one there, we have a Markovnikov's rule. So it says to determine which product is formed, we use Markovnikov's rule, which states that in an addition reaction, the hydrogen attaches to the carbon with the greater number of hydrogen atoms, therefore a major product will be formed. Okay? So if we have an addition reaction, let's say as an example, if we have, if we have a total of, or let's use the double bond on this position, and if we have a total of 4 carbons, on those carbons we want to be adding HBr. So Markovnikov, it states that the hydrogen attaches to the carbon with the greater number of hydrogen atoms. So what does that mean? It means that, so on carbon number 1, you will see that we have a total of what? We have a total of 2 hydrogens. Let me write 1, 2, 3, and 4. So on carbon number 1, we have a total of 2 hydrogens, and then on carbon number 2, we have a total of what? A total of 1 hydrogen. So it says in an addition reaction, the hydrogen, so if we want to be adding this HBr, it says the hydrogen will attach to the carbon with the greater number of hydrogen atoms. So it means that between carbon number 1 and carbon number 2, that is where we are going to be adding the HBr. So how are we going to decide on that? We are going to use a Markovnikov's rule. So we need to add this hydrogen and the bromine. So it's either we can add the bromine on carbon number 2, or we can add the bromine on carbon number 1, or vice versa, add the hydrogen on carbon number 2 or hydrogen on carbon number 1. But the rule says carbon will be attached to the hydrogen that has a greater number of hydrogens, to the carbon that has a greater number of hydrogens. So between carbon number 1 and carbon number 2, which one has the greater number of hydrogens? We can see that carbon number 1 has the greater number of hydrogens. So it therefore means that if you are to add the hydrogen, you will need to add it on carbon number what? On carbon number 1, and then the bromine you will need to add it on carbon number 2, because Markovnikov says that you need to add the hydrogen to the carbon that has the greater number. So carbon number 1 on this molecule, it had what? It had 2 hydrogens. So if it already has more hydrogens, then we are going to add an extra hydrogen. So there is our extra hydrogen that we added, and it therefore means that the bromine will be added on carbon number what? On carbon number 2. So this will therefore be called a major product. But what if you now decide to swap them around and then you add the bromine on carbon number 1 and then you add the hydrogen on carbon number 2? So it means that you did not obey what? Markovnikov's rule. So if you decide to do it in this way, it means that you have now formed what? A minor product. But if you follow Markovnikov's rule, it means that you have formed what? A major product. Okay. And then we have your substitution reaction. So for a substitution reaction, we are given a butane, and then it says that our butane is what? Is saturated. So we have sunlight as our reaction condition, and then we are going to be substituting Br. Okay. So from here, what is it that you are going to do? So with substitution, we are just going to be substituting the one bromine there. And in this case, because we do not have any guidance as to where to substitute, it means that you could have substituted on any of the hydrogens. So in this case, it was substituted where? On carbon number 2. So we took this bromine here, substituted on carbon number 2, and it therefore means that you no longer have what? You no longer have the hydrogen there. So if you had Br, and you substitute only one Br, what is it that you are left with? You are left with a Br and a hydrogen. So therefore, the other product that will be formed will therefore be what? Your HBr. So from there, so this reaction would be called what? Would be called your halogenation, where you are forming a haloalkane. So from there, what is it that you have? You have a Br which is already substituted, but you want to substitute with what? With your water, which is a HOH. So what is it that you are going to do? So this reaction is hydrolysis, and one of the reaction conditions will therefore be your heat. So what is it that you are going to do? You have water, of which it becomes H and what? And OH. And you need to form what? You need to form an alcohol. So you are substituting this water where you have the Br. So it means that you no longer have the Br because you substituted the Br with your what? With your OH. And then what is it that you have left in terms of the water? You have H and the Br that you removed. So your other product that will be formed will therefore be your what? Your HBr. So what is it that you did there? You substituted your Br with your OH. And where is that OH going to be substituted? It is going to be substituted by carbon number 2. So even if it can be carbon number 2 from the left hand side, it does not matter, as long as it's going to be on position number 1, on position number 2. Okay, learners, we are now going to be taking a 1-minute break. Welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. So if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. Okay. So going back to this one here, we said that the bromine was substituted with what? With the OH. And from the water, what is it that you were left with? You were left with the H, which is your hydrogen, and you were also left with your Br, which is your Br, of which you removed when you were substituting. So it means that you are, in this case, it means that you are going to have two products. So you will have this product that has an alcohol, and then you'll also have your HBr. So we said this type of reaction where you substitute with what? With water is therefore going to be called what? Hydrolysis. Then next, you are substituting Na and your OH. Na and your OH. So this one again is therefore called a hydrolysis. So how do we do this one? On carbon number 2 again, what is it that we have? We have Br, and then this Br, where do you want to substitute it? You want to substitute the OH where you have what? Where you have the Br, that is on carbon number 2. So once you substitute, then you no longer have a Br on carbon number 2, but what is it that you have? You have an OH. So because you removed the Br, and from the sodium hydroxide, NaOH, you were left with what? You were left with the NaOH. So it means that you were left with the Na, and you are left with what? With the Br. So it means that the other products that you are going to form will be the Na that you did not use when you were substituting, and the Br that you removed when you were substituting with the OH. So again, we'll have two products. We'll have this one and the NaBr. Okay, then moving on to the next one. So this one, you are substituting with what? With HBr. And when you substitute with your HBr, you have a H and a Br separately. So you will substitute the Br where you see what? Where you see the OH. So if you substitute the Br where you see the OH, it means that the OH is now out, and which other products are you left with? So you will be left with the hydrogen that you did not substitute, and you'll also be left with what? With the OH that you removed. So if you think about it, the H and the OH, what is it that they are going to form? So the H and the OH, they are going to be forming what? Your H2O. So your other product will therefore be what? Will therefore be your water. So again, where did we substitute the Br? We have substituted the Br by carbon number what? By carbon number 2. So in this case, does it matter if the Br is at the top or it's at the bottom there? In this case, it does not matter where it's written, as long as the Br will be on carbon number what? On carbon number 2. So the same goes for all of them. Does it matter if the OH is written at the top or it's written at the bottom? Since that is where we substituted the what? The Br. It does not matter if the OH is at the top or at the bottom, but as long as the OH is on carbon number what? On carbon number 2 there. So the acronyms to remember the reaction by. With the addition reaction, we had USA. So USA, it means that, so this line would mean that we have the reactants, and then this line, it means that that would be our product, and then this one will be the type of reaction that we have. So in terms of the reactants, we are saying when it comes to your addition or substitution reaction, then we are saying you are going to use the word USA. So if the reactant is, the first letter there is U, is unsaturated, remember with addition reaction, the reactant is what? The reactant is an alkene, it has double bonds. So because it has double bonds, it therefore means that it is what? It is unsaturated. So you'll be moving from a reactant that is unsaturated, and then you are going to be moving to a product which is saturated. So therefore, the type of reaction that you would have there will be what? Will be addition reaction. And then for substitution, we are saying that if the reactant is what? Is saturated, so meaning there will be no double bonds and no triple bonds, the product is also what? The product is saturated, therefore the type of reaction will be what? Will be your substitution reaction. So what you need to do is that when you go to the exam, you need to remember this, and you also need to use this as well when you do your activities, as it is going to make your reactions easier. So USA, it means the reactant is unsaturated, the product is saturated, therefore addition reaction. And then triple S, we are saying the reactant is saturated, the product is saturated, therefore the type of reaction will be what? The type of reaction will be substitution there. So we have activity 1 there. It says the flow diagram below shows some of the reactions of propene. So we are starting here of propene. Then it says what type of reaction is represented by the following letters. Okay, so we have letter A, and then we also have what? By 4.1.2 we have letter B. Okay, so if we have propene, we already know that propene will be what? Will have, because of the the homologous series of propene is what? Is alkenes. So therefore it means that the propene will have what? Will have your double bonds. Okay, so because it has double bonds, what is it that you are going to use? You are going to use USA and what? And your triple S there. Because it has double bonds, this is your starting point. So your starting point, that is your reactants, which are on the left hand side of the reaction. Propene will be unsaturated because it has double bonds. So already you can see that it's either you are going to be dealing with what? Unsaturated or what? Or saturated. But you can see that you have propene, it has double bonds, so therefore propene is what? Is unsaturated. So because it is unsaturated, and then going on to this one is your propane. And how can you tell? You can also draw the propane to verify. So this propane has how many carbons? We can see that it has 3 carbons because it says what? C3. And it has how many hydrogens? It has 8 hydrogens. So this is 5, 6, 7, and 8 hydrogens. So this would represent your structure for what? For the propane. And then you are moving from a double bond, which is unsaturated, to a product that is saturated because we do not have double bonds or triple bonds. So therefore, what is the type of reaction? It is therefore going to be what? It is therefore going to be an addition reaction. But what type of addition reaction? If you are moving from a propene, so this would be the structure of a propene. If you are moving from a propene to get to a propane, so from an unsaturated because it has double bonds to saturated because it does not have double bonds, what is it that you have added so that you can get to the propane? We can see that you have added what? The 2 hydrogens. So therefore, the type of addition reaction will be what? A hydrogenation. Then the next letter there is letter B. So we are moving from, again, unsaturated. So it's going to be in between what? Addition and substitution. So immediately you can see that you are moving from unsaturated. It means that the alcohol is what? Is saturated. So therefore, again, it is going to be what? It is going to be an addition reaction. But what type of addition reaction is this? So whenever you see that you are going to be forming an alcohol, then you know that what is it that you have added? You have added H2O. Okay? So if you have added H2O, it means the type of addition reaction would therefore be called what? Hydration. Then the next one, it says use structural formulae to write down a balanced chemical equation for the letter C. So what is it that we have by the letter C? Again, we are starting with what? We are starting with propene. So how are you going to tackle this one? We are starting with propene. You know that propene, the homologous series of propene is what? Is alkene. And that alkene has, it's an alkene because it has a name ending in. And how many carbons are you going to draw for this one? You will have a total of 3 carbons. You will also have a double bond. And what is it that you need to add? You are going to be adding a HBr. Okay? So this would therefore be your structure. But if you have it in this way, so you have an H and a Br, how do you then decide where to add the hydrogen and where to add the bromine? You are therefore going to be using Markovnikov's rule. And what did Markovnikov say? It said that the carbon with the greater number of hydrogens is the one that will get what? That will get the hydrogen. And then the carbon with the least will therefore be getting the halogen there. So that is why your bromine will be added on carbon number 2, and your hydrogen will be added on carbon number what? On carbon number 1. Again, with Markovnikov, we can also call it as the rich will get richer. So meaning that the carbon that has the greater number of hydrogen again, so the carbon that is rich with hydrogens will get even more hydrogens. So again, for example, carbon number 1 from the right hand side has what? It has 2 hydrogen. So if it is going to get richer with more hydrogens, it means that we need to add what? We need to add 1 more hydrogen, and therefore it means that the carbon with the least number of hydrogens will therefore be getting the bromine. The next one says name the type of reaction that occurs when propene is converted to what? When propene is converted to compound X. So we need the type of reaction. Again, you can use a USA and what? And a triple S. So where are we moving from? We are moving from an unsaturated compound. Why is it unsaturated? Because it has what? It has double bonds to a saturated compound. So if we are moving from unsaturated to saturated, therefore the type of reaction will be what? The type of reaction will be an addition reaction. Okay, so it will be an addition reaction, but what type of addition reaction? What is it that we are adding? We can see that we are adding a hydrogen and a halogen. So therefore it would be called a hydro for the hydrogen and a halogenation for the halogen, which is what? Which is bromine that we are adding over there. Okay. Okay, learners, I'm going to ask that we take a 2 minutes break. Welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. So if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. So the next question that we have here, it says write down one reaction condition necessary for reaction C2 to OK. So we said that when we move from propene, which is unsaturated, to compound X, which we said it was saturated, we therefore said the type of addition reaction. We said the type of reaction was an addition reaction. So we said it is the addition of what? Of a hydrogen and a bromine. So what would be the reaction condition? And then it says here, water should not be present. Then 4.5 says write down a balanced molecular equation for the reaction that will occur when C3H8 reacts with excess oxygen. So when it reacts with excess oxygen. So remember, whenever they speak of excess oxygen, it means that they want you to do either a combustion or oxidation reaction. And remember, we said combustion or oxidation, it means that they want you to write exactly the same thing. So what are the constants that you are going to have there? So remember, we said with the combustion reaction, the constants will be your O2 as a reactant, and then on the right hand side you have CO2 and your water as well as your constant. And then remember, we said that you also need to make sure that the reaction is what? The reaction is balanced there. So again, we said as a constant you will have your O2, you will have your CO2, and then you will have your water as constants. But what you need to do is that you need to make sure that the reaction is balanced. So what is it that you initially write? You will write your C3H8 plus by what? Plus by your O2, and then to give us what? CO2 plus H2O plus by what? Plus by the energy there. So you need to make sure that the carbon, the hydrogen, and the oxygen on the left hand side are balanced, as well as the carbon, the hydrogen, and the oxygen on the right hand side. So firstly, you need to check how many carbons you have on the left hand side. So we can see that we have 3 carbons there. And how many carbons do we then have on the right hand side? We have 1 carbon. How many hydrogens do we have on the left hand side? We have 8. And how many on the right? We have 2 hydrogens on the right. How many oxygens on the left hand side? We can see that we have 2. And how many oxygens on the right? So we have 2 plus by what? Plus by 1, which gives us a total of what? Of 3 oxygens. So then you can check between carbon, hydrogen, and oxygen, you can check what is it that you can balance. So we can see that between the 3 of them, none are balanced. So we can then put a big 3 there on the CO2. And when we do that, it means that we will now have a total of how many carbons? It will be 3 multiplied by 1. So we now have a total of what? Of 3 carbons. Then the carbons are now balanced. So what is it that you can balance next? You can then balance your hydrogen. So on the left hand side you have 8, and on the right hand side you have what? You have 2. So what is it that you can do? You can therefore put a big 4 there. When you put a 4, it will be 4 times 2. So therefore you will have a total of 8 hydrogens. So again, you'll see the carbons are balanced, the hydrogens are balanced. And then what is it that you need to balance now? You need to balance your oxygens. So with the oxygens on the right hand side, it's 3 times 2 from the carbon dioxide. So you have 6 there by the carbon dioxide, and then it's 4 multiplied by 1 oxygen there. So plus by 4, so it means that you now have a total of what? Of 10 oxygens. And then on the left-hand side, how many oxygens do you now have? You have 2 oxygens. So therefore, what is it that you can do to balance the oxygens on the left and the oxygens on the right? So if you have a 10 here, you can put a big 5 there on the oxygen. So therefore 5 multiplied by 2 will therefore give you a total of what? A total of 10 oxygens. So from there, you can double check that the carbons, the hydrogens, and the oxygens on the left are balancing with the carbons, the hydrogen, and the oxygens were on the right hand side. Okay. And then the next one says you need to define the term monomer. So again, remember with the definitions, you are either going to be getting 2 marks or nothing. There will be no half marks in terms of definitions. So a monomer, it says small organic molecules that can be covalently bonded to each other in a repeating pattern. The next one says, name 2 uses of polyethylene. So remember we said the word poly, it just means that we have many of the ethynes. So now they want you to name 2 uses. So it says here to manufacture plastic containers, plastic bottles, or plastic shopping bags, and what can be acceptable can also be any plastic product that will also be acceptable as an answer to this question here. The next one says the following represents part of a polymer. So the following represents part of a polymer. Then it says you need to define the term polymer. So again, definitions will be 2 marks. You are not going to get half a mark for definitions. So it says a large molecule composed of smaller monomer units bonded to each other in a repeating pattern. Then 3.3.2 it says give the name of the polymer. So remember we said polymers, they come from where? They come from monomers. So in this case, the name of the polymer would therefore be called a polyethylene. So we said poly, it means many. So many of the ethynes. So it means the monomer was therefore called what? An ethene, but the polymer, so many of the monomer units would therefore be called what? Polyethylene. Then it says consider the flow diagram below and then answer the questions that follow. It says compound B is formed when but2-ene. So we have compound B that is formed when but2-ene reacts with hydrogen gas in the presence of a catalyst. And then it says you need to write down the IUPAC name of compound B. So how will you write down the IUPAC name of compound B? Your guidance will be what? Your guidance will be the but2-ene. And it says here it's going to be what? It's going to be butane. So how did you get to the butane? With the but2-ene, it means that you have a double bond because of the ene, so you have an alkene, and you have a double bond on carbon number what? On carbon number 2. So if you have a double bond on carbon number 2, on the first carbon, you are therefore going to have 3 hydrogens, the second one, 1 hydrogen, the third one, and the last one, you are therefore going to have what? 3 hydrogens as well. So on carbon number 2, so 1, 2, 3, 4. On carbon number 2, you have but2-ene. So carbon number 2, you have what? You have a double bond because of the what? Because of the ene there. And what is it that you are adding so that you can get to compound B? You are going to add H2. So when you add H2, you can either add it on carbon number 2 or on carbon number 3. So H2 therefore becomes what? H and H. So where are you going to add it? If you add it on carbon number 2 or on carbon number 3, it is not going to make what? Any difference. So therefore, your structure will therefore be that. On the first carbon, 3 hydrogens, second carbon, 2 hydrogens, the third one, 3, and the last one, the third one, 2 hydrogens, and the last one, you have what? 3 hydrogens. So therefore, the addition of the 2 hydrogens will therefore be represented by that. So you are moving from an alkane to a what? To a. You are moving from an alkene to an alkane. So you have now added the 2 hydrogens, so therefore the name would therefore be what? It would therefore be called a butane, because you no longer have what? You no longer have the double bonds on carbon number 2 and carbon number 3. Then 4.1.2, it says name or the formula of the catalyst that is used. So the name or the formula of the catalyst that is used for what? For this type of reaction. So which type of reaction? Where you are adding what? Where you are adding H2. So because it says the name, it means that you can either give the name, for example, platinum, or you can give the formula, which is what? PT. Again, you can give the name nickel, or the formula, which is what? Which is Ni. And then palladium, or the formula, which is what? Which is PD. So if they say you must give the name, then it means that you are only going to give your platinum, your nickel, or your palladium. But if they say you must give the formula only, then it means that you need to give what? PT, Ni, and your PD. Then it says, when HBr reacts with but2-ene, a haloalkane, which is compound A, is formed. Then it says, name the type of a reaction that takes place. So again, what is it that you are going to use? You have USA, and then you have what? You have triple S. So when you have your USA there, it means that you now need to check, are you moving from an unsaturated compound or from a saturated compound? So if you are going to be moving from what? From but2-ene. But2-ene, what is the homologous series? It is an alkene. So because it is an alkene, we now know that but2-ene will therefore be having what? Double bonds. So if it has double bonds, it therefore means it is what? It is unsaturated. Okay, so because you are moving from unsaturated, then it means that the next one, so the reactant, this one, it will be on the left hand side, is unsaturated. It therefore means the product, of which when you write the reaction, it will be on the right hand side, it will be what? It will be saturated. Therefore, the type of reaction would therefore be what? Would therefore be your addition reaction. But what type of an addition reaction is this? What is it that you are adding? You are adding a hydrogen, so therefore hydro and a what? And a halogen. So therefore it will be called what? Hydrohalogenation, because it's the addition of what? Of hydrogen and a halogen. When you combine hydrohalogenation. Then 4.2.2, it says, write down the structural formula and the IUPAC name of compound A. Okay. So again, what is it that you are moving from? You are going to be moving from a but2-ene. But2-ene, we said it means that it is an alkene. The homologous series is an alkene. So by the ene, it means that we have a double bond. Where do we have a double bond? We have a double bond on carbon number 2. So therefore, the first carbon will have 3 hydrogens, the second and the third, 1 hydrogen each, because remember the carbon must have a total of what? Of 4 bonds. So this is your but2-ene, and what is it that you are going to be adding? you are going to be adding the HBr. So when it comes to this one, you are not going to be using a Markov-Nikov, because in this case, carbon number 2 and carbon number 3 both have how many hydrogens? So both have one hydrogen. So it means that in this case, if you want to add the H and the Br between carbon number 2 and carbon number 3, you can therefore add them at any position. So you can add the Br on carbon number 2 and the hydrogen on carbon number 3, or you can add the Br on carbon number 2 from the right hand side and the H on carbon number 2 from the left hand side. So it says write down the structural formula. So this would be our structural formula, and then they also said that you must write the IUPAC name of what, of compound A. So what would be the IUPAC name? We can see that we have a total of what? We have a total of 4 carbons. So therefore it would be called a butane. But on carbon number 2, what is it that we have? We have a bromo. So you would write it as 2-bromo and then butane. Why? Because we have a total of what? 1, 2, 3. So it's 1, 2, 3, 4 hydrogens. So 2-bromo butane would therefore be the name of the compound there. Then it says compound C is formed when but2-ene. So where's our compound C? This is our compound C. It is formed when but2-ene reacts with what? With H2O. It says name the type of addition reaction that takes place. So already on this one, they told you that it is an addition reaction. So it means that even if you use the USA and the triple S, in this case, you cannot use that because they already told you that it is an addition reaction. So now they want you to name the type of addition reaction that we have. So you already know that if it's an addition reaction, you are moving from unsaturated to a saturated compound. But if you are going to be adding water, what is the type of addition reaction? So the type of addition reaction would therefore be called what? Would therefore be called the hydration. Then 4.3.2, it says write down the structural formula of compound C. So again, you are moving from but2-ene. But2-ene, it has a total of how many carbons? It has a total of 4 carbons. And then between carbon number 2 and carbon number 3, what is it that you have? You will have a double bond. So it says write down the structural formula of what? The structural formula of compound C. So again, we have a total of 4 carbons. Between carbon number 2 and carbon number 3, what is it that we have? We have a double bond. And what is it that we need to add? We need to add H2O, and the H2O will be divided into what? Into H and OH. So you know that between carbon number 2 and carbon number 3, you need to add H and OH. So again, in this case, you are not going to use Markov-Nikov. Why? Because carbon number 2 and carbon number 3 have an equal number of hydrogens. So it means that in this case, you can add your hydrogen on carbon number 2 and your OH on carbon number 3, or you can write it in this way, where you have your OH on carbon number 2 and your H on carbon number 3. So in both ways, that would still be correct. Then it says, is compound C a primary, secondary, or a tertiary alcohol? So now they're asking you, with the very same compound that you have now drawn, with the very same structural formula, is this compound a primary, a secondary, or a tertiary alcohol? So we can see that because the OH group is attached to the carbon, which is attached to two other carbons, it therefore means that we have a secondary alcohol. So because the OH group is attached to the carbon, which is attached to two other carbons, therefore it means that we have a secondary alcohol. But if it was a primary alcohol, then the OH group, so if it was a primary alcohol, it means that in this case, on the first carbon, that is where we'll have what? That is where we will have the OH groups there. So therefore, we would therefore say that the OH group is attached to the carbon that is attached to what? To only one other carbon. So, but now this one, because it's a secondary, the OH group is attached to the carbon that is attached to what? To two other carbons. Then 4.4, it says name the inorganic compound. Name the inorganic compound D. So with this one, we can see that we are moving from what? We are moving from but2-ene, and we have the addition of what? We have the addition of O2, and we can see that we are forming CO2, we are forming compound D, and we are also forming what? The energy there. So what would be compound D? In this case, it means that we have what? We have a combustion or oxidation reaction. Why? Because we have an alkene, we are adding an O2, and the product is CO2. It will be water plus by what? Plus by energy. But because in this case, they said you must name the inorganic compound. So because they said we must name, you are therefore going to write the name as water, and you are therefore not going to give them the molecular formula there. Okay, and we have the next one over here. So before we do this one, learners, I'm going to ask that we take a 1-minute break. Welcome back, learners. Again, if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. If you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. So the next one here says the flow diagram below show how ethene can be used. So how ethene can be used as a starting reactant to manufacture a variety of organic compounds. Then it says letters A, B, and C represent different types of reactions. So this one says name the type of addition reaction that is represented by the following letters. So we have the first one there. Remember we said with an addition reaction, we are moving from what? From an unsaturated to a saturated compound. But now they already told us that we have an addition reaction. Now we need to give the type of what? The type of addition reaction. So with this one, with an ethene, the homologous series of ethene is what? Is our alkenes. So it means that we already know that the alkene will therefore have what? It will therefore have a double bond. So it will therefore have a double bond. And ethene has a total of how many carbons? It has a total of 2 carbons. And in between those 2 carbons, we'll have what? We'll have the double bond there. So for letter A, we are moving from ethene to what? To ethanol. So it means that for us to move from this ethene to the ethanol, what is it that was added? So again, ethanol has how many carbons in total? It has 2 carbons in total. And on the double bond, what is it that we are going to add? So we are going to be adding H and OH, and of which the combination of the two is what? Is water. So the addition of water to an alkane, therefore the type of addition reaction would therefore be called what? Hydration. So we added water between carbon number what? Carbon number 1 and carbon number 2. So again, on this one, we are not going to be using Markovnikov's rule. Why? Because both carbon number 2 and carbon number 3, they have a total of what? They both have a total of 2 hydrogens. Then the next one says, name the type of addition reaction again for B this time. So with B, again, we are moving from what? An unsaturated compound to a saturated compound. We already know that the type of reaction is what? Is addition. But now they said we must give the type of addition. So bromoethane, a bromoethane, it means what? It means that you have a bromo there and you also have what? An ethane. Ethane has how many carbons in total? It has a total of 2 carbons. And then what is it that you have? You will have 3 hydrogens. 3 hydrogens and what? And a bromo. So with the three hydrogens on the first carbon and 2 hydrogens on the second carbon, plus by the bromine there, it therefore means what is it that you added on carbon number 2 and carbon number 3? So on this one, we added hydrogen and a bromine. So the addition of hydrogen and bromine, the type of addition reaction would therefore be called what? Halogenation. So that is the addition of your hydrogen and the addition of a halogen. So therefore it's called what? A hydrohalogenation. Then the next one is your letter C. So letter C, you are moving from an ethene. Ethene, the homologous series is what? Is your alkene to an alkane. So with an alkane, you already know that you are not going to be having what? You are not going to be having the double bonds. So your alkane, given direction from the ethene, it means that your alkane will be having a total of what? Will be having a total of 2 carbons. So if you are going to be moving from an ethene, which has a double bond there, to an alkane, what is it that you need to add? You will need to add 2 hydrogens. So therefore, the addition of 2 hydrogens would therefore be called what? Hydrogenation. So hydrogenation is just the addition of what? The addition of the 2 hydrogens there. Then 5.2, it says for reaction A, write down the name or the formula of the catalyst that is used. So for reaction A, what is it that you are moving from? So again, if you use a USA and then what? And then triple S. What is it that you are moving from? You are moving from an unsaturated compound. Why is it unsaturated? Because of this ethene. So unsaturated compound, you know that the next one is therefore going to be what? Saturated. So we said it is an addition reaction, But what type of addition reaction? If you are going to be moving from an ethene to an alcohol, what is it that you are adding? You are going to be adding water. So we said the type of addition is what? Is hydration. So now it says write down the name or the formula of the catalyst that is used. So the name or the catalyst that is used for hydration would therefore be called what? So if you are going to write the name, that would be your name, sulfuric acid. But if you are going to write the formula, then H2SO4 would therefore be your formula. 5.2.2, it says use structural formula. Write down a fully balanced chemical equation for the formation of what? For the formation of the ethanol. So what is it that you are going to have? You are going to have your ethene. Your ethene, we said the homologous series is what? Is alkene. And if it's alkene, it means that it will have what? It will have a double bond. So ethene has a total of what? It has a total of 2 carbons. And we said total of 2 carbons plus what? Plus the double bond. So we said what is it that you are going to be adding? For you to move from an ethene to an ethanol, you are going to be adding water. So therefore, if you add water, so remember your water can also be represented as what? Or from the water, you are going to have what? Hydrogen and what? And OH. So the hydrogen and the OH, the hydrogen will have to attach to one of the carbons. So the hydrogen can attach to one of the carbons, and your OH will also attach to one of the other carbons as well. So therefore, this is how you would represent your structural formula for, where you move from what? Where you move from your ethene to your ethanol. And again, remember we said this type of reaction is called your what? It's called hydration. Why? Because we said it is the addition of what? The addition of your water there. Then it says for reaction B, 5.3.1, write down the formula of the inorganic reactant that is needed. So the inorganic reactant that is needed for reaction B. So again, what is it that you are moving from? You are moving from an unsaturated compound to a what? To a saturated compound. So we already know that this is going to be what? This is going to be an addition reaction. But the question says the inorganic reactant that is needed. So what is it that you are moving from? You are moving from an ethene. Ethene, we said the homologous series is what? Is alkene. It has a total of what? Of 2 carbons. So therefore, between the 2 carbons, we are going to have what? We are going to have double bonds. But we are moving to a bromoethane. So a bromoethane has a total of what? Has a total of 2 carbons again. But this one, this time is what? The homologous series will be a haloalkane because of the bromo there. So what is it that you are going to have? So you have the very same structure as your alkene there, but what is it that you are going to add? You are going to add a hydrogen and a bromine there. So it says write down the formula of the inorganic reactant. So remember your reactants are on the left hand side of the equation, and then your products are on the right hand side of the equation. So in terms of the formula of the inorganic reactant that is needed, so it means that if you are going to be moving from an ethene to a bromoethene, what other reactant can you add so that you can get to your bromoethane? So we can see that on position number 2, on position number 1 and position number 2 on the ethene, initially we did not have anything, but when it became a bromoethane, what is it that we had? We had a hydrogen and a bromine. So therefore, the hydrogen and the bromine would therefore be representing the what? the other inorganic what? The other inorganic reactant, so that you can get what? So that you can get the bromoethane. Okay, so if you were to write out the reaction, you would have the ethene plus by what? Plus by the HBr, the arrow, and therefore you will be getting the bromoethane as a product. Then it says write down one condition for the reaction to proceed. Okay, so the addition reaction where you add what? A hydrogen and a halogen. What is the reaction condition for the reaction to do what? To proceed. So the reaction condition would therefore be what? No water must be present. Then it says for the combustion reaction, write down the 5.4.1, the name or the formula of the excess reactant. That is what? That is gas X. So remember, we said combustion or oxidation reaction. It means that in terms of the examinations, they're asking for exactly the same thing. So it says name or the formula of the excess reactant. So of the excess reactant. So our keyword here will be excess reactant, which is what? Which is gas X. So remember we said in terms of a combustion reaction, you are either going to have an alkane or alkene, and what is it that will be constant? It will be your O2, which is your oxygen. On the left hand side is your reactant, and then as your products, your constants will be CO2, H2O, and what? And your energy as well. So in terms of the reactant, your reactant will therefore be called what? Oxygen gas, or your O2 there. So because they said the name or the formula, the name is oxygen gas, or the formula, you could have written what? O2 there. Then 5.4.2, it says the name or the formula of the products that will be formed. So in terms of the products, again, we said as constants, we are going to have what as a product? We are going to have CO2, H2O, and what? And energy as a product. So because they said the name or the formula, you can either write carbon dioxide or what? Or CO2, or you can write water or your what? Or your H2O. So this would therefore be the product. So for the combustion reaction, they were moving from an alkane, they added O2, and the products were therefore CO2 plus H2O. So it was an alkane plus O2 to give CO2 plus by H2O as your products, plus by energy there. Okay, so with that, learners, I'll leave you with the words of Nelson Mandela, which says it is in your hands to create a better world for all who live in it. Thank you very much. I'll see you next time at the same place. Thank you.